I'd like to welcome everybody to the Algebra 2 Chapter 4a review guide video. So we've got this test coming up, and there were quite a few things that were happening in there, some that we had already known, some that are new. So let's get started. I'm just going to let you know this may be a longer video. There's a lot of writing and explaining going on. So if you totally get a concept, feel free to skip around on the video. If you need to rewatch something because I'm talking too quickly, I apologize. But of course, with the magic that is YouTube, you can go back and watch each of these examples again. So let's get started. All right, now this looks a little bit different than our test, but at the same time, it's testing the same types of skills. So for problems 1 and 2, we're dealing with what are some of the vocabulary that goes along with polynomials. We need to look at the degree, the leading coefficient, and the end behavior, and then what type of function it is. All right, so for problem number 1, we've got some function g of x. I'm just going to take a quick scan of the exponents there, and you can see x to the fourth, x to the second, x to the first, and then just a constant at the end. It is in standard form, so all of this information can be found from that leading term. We learn an awful lot from that. I can see because of the fourth power that is a fourth degree polynomial, its leading coefficient leading off that fourth power term is a -3. The end behavior, because it's even degree with a negative leading coefficient, is that it falls left and right. All right, there is an opportunity for extra credit whenever we're talking about end behavior. If you were to say the height approaches negative infinity as x approaches negative infinity, that's saying the same thing as falls left. And f of x approaches negative infinity as x approaches positive infinity, that's our way of saying it falls to the right as well. So if you take the time to learn that language, that is worth an extra credit point on my test. Okay, because it is a fourth degree, we do have a special name for that. That is a quartic function. And we're done with problem 1, mostly identifying using our vocabulary. Little warning as we look at problem 2, quick scan of the exponents. I got first power, third power, a constant, and then x squared. It's not in standard form. So the leading term should be this positive 2/5 x cubed. That's the term with the highest exponent on x. That's indicating that it's a third degree with a lead coefficient of 2/5. Its end behavior, because it's an odd degree with a positive leading coefficient, means that it rises to the right and falls to the left. Okay, again, we could say that f of x, the height approaches infinity as x approaches infinity. That's our way of saying rises right. And f of x, it's falling, so approaching negative infinity as I go to the left. That's as x approaches negative infinity as well. Again, that would be another extra credit point if we take the time to learn that language. All right, and if it's third degree, that is a cubic function. We do have a special name for that. So there we have it. All right, problems 3 and 4. Here what we've got are looking at a graph stating the number of real zeros. Those are intercepts that we see happening on the x-axis and approximate the x values where the function is increasing and decreasing. Okay, well, the number of zeros that I see in number 3, 1, 2, 3, 4, 5, there are 5 places where that graph crosses the real x-axis. Okay, so 5 real zeros, no imaginary ones there. It is increasing wherever the graph is rising to the right. So here it's increasing, and here it's increasing. So I would say all x's that are less than -4, oh sorry, not -4, it's like somewhere in here. So let's say -3.5. Then from x equals -1 to x equals +1. So when -1 is less than x, which is less than 1. And then finally, it looks like when x is greater than 3.1 or 3.2, those are places where the graph is increasing. Now, this is not something that is heavily stressed on this test. So if we are still kind of grappling with increasing, decreasing, we're going to do more work with that once we get to the second half of chapter 4. Okay, lastly, where's it decreasing? I'll choose a different color for this. That's where the graph is losing height, where if a car is traveling left to right across that graph, where's it going downhill? Here it's when x is between negative 3.5 and negative 1, and then also when x is between 1 and positive 3.2. Again, we're just estimating there. Can't say for certain. Let's try problem number 4. How many real zeros does this graph have? Let's go in blue. Well, it crosses the real x-axis twice, 2 real zeros. Okay, it is increasing. Let's see, if my car is traveling left to right across that graph, it's going uphill those 2 places. And if we're estimating, I would say it's increasing from when x equals negative 3, maybe negative 2.9 even, up until I get to, oh boy, what might I say that is? Negative 1.5. And then also when x is greater than maybe 1.5. And then it's decreasing, car going downhill here and here on the graph. That's when x is less than that negative 2.9, or when x is between that negative 1.5 and that, what do we say that was, positive 1.5? So again, just describing the graph. Again, the increasing, decreasing is not as heavily stressed on this test as these problems would lead to believe. So if we're still kind of iffy on that, do not worry. It's not a heavily tested concept. All right, so there's our opening part of the test. Then we start getting into some of the algebra with it, past the vocabulary. This would be our work from section 4.2, and we're adding and subtracting polynomials. Really, we are just combining like terms, and we want to be careful that we are distributing negatives wherever they need to be distributed. So in the case of problem number 5, I've got one polynomial and I'm subtracting another. That negative here is going to distribute to everything inside. So it's really a negative 4x squared, a negative x, and a positive 3 when I go to combine my like terms. 6x squared and negative 4x squared is 2x squared. Negative 3x and another negative x is negative 4x. 2 and 3 make a positive 5. There's my answer. We should not be spending a whole lot of time on these during the test. For number 6, you can see I'm just adding these up, so there's no need to distribute a negative. I'm just combining like terms. Negative 2x squared and another negative 2x squared, that's negative 4x squared. Negative 3x and another negative 3x, that's negative 6x total. Negative 5 and positive 8 plus 3 when I combine those like terms. We are done. For number 7, there's another negative that needs to be distributed here. So it's really negative 6a cubed, positive 7a squared, and negative 1. And if I combine my like terms, I end up with negative 4a cubed. My a squareds are going to cancel out. I've got negative 7 of those and positive 7 of those. They will zero out when I combine them. I do have a positive a with no other a terms to combine that with, and then a negative 1 as well. So when all the like terms have been combined, that should be our final answer. Alrighty. For the next section, we are multiplying polynomials, and that means just a lot of distribution and foiling involved. We also learned how to use Pascal's triangle to expand, so we'll talk about that when we get to problem number 9. Number 8, when I distribute this out, I'm going to start by taking the first term in that first factor, this w squared, and distribute that to both parts of the second factor. So I've got w squared times w squared times 2s. Okay, now let's do the next term. I'm going to distribute this negative 2ws. So I get minus 2w squared s, right? Inside there's a w times w. And then negative 4ws squared. All right, and then lastly, we'll distribute this 4s squared. So I get plus 4s squared w and plus 8s to the third. And then to put the final answer down, I'm simply going to combine my like terms. I have no other w to the third terms. I have, let's see, one term that's w squared s, so minus 2w squared s. Then, oh, I'm sorry, this should have been an sw squared. So as I'm looking back at my distribution, when I did w squared times 2s, that should have been a squared. I apologize for that. That does combine with something else. So this sw squared and this w squared s, those are like terms, and actually they cancel out. Awesome. Then this negative 4ws squared and this positive 4sw squared, when I combine those like terms together, they cancel out. Lastly, I have 8s to the third power, so all the like terms combined, it simplifies quite a bit. That should be our final answer. For problem number 9, this one, I would put a star next to this because on the test, I believe, if I remember correctly, we do not have you expand powers that are bigger than 3 when we're raising a binomial to a power. So this is a little bit more difficult than what you can expect to see on the test. But again, we want the practice to be a little tougher so that the test itself seems easy. Because it's a fourth power, I'm thinking of the fourth row in Pascal's triangle that goes 1, 4, 6, 4, 1. That's going to be my set of coefficients. I notice the first thing is a y and the second thing is a negative 8 inside that binomial. So here's how we're going to follow the pattern to make this happen. My coefficient of 1 from Pascal's triangle times the first thing to the full power times the second thing to any remaining power that we've got. Since all of it's with y, we've got nothing left to go with that negative 8. Next term, I've got 4 times y to the drop the power 1 times negative 8 to the remaining power. Next term, 6 times y to the, let's drop that exponent, times negative 8 to the remaining power. 4 times y, let's drop that power 1 times negative 8 to the remaining power. And then lastly, plus 1 times y to the drop the power once, negative 8 to the remaining power. Now the second thing, that negative 8 gets all the power. And here's where we may use a calculator to kind of simplify our work along the way. I've got 1 times y to the fourth times something to the 0 power plus 4 times y to the third times a negative to an odd power is negative. It's going to keep its negative sign. Plus 6 times y to the second times a negative to an even power stays positive. The negative sign is absorbed. Plus 4 times y to the first power times, negative to an odd power, so negative 512. Then my final term is 1 times something to the 0 power times a negative to an even power. Use the calculator to find that 4,096. And our last step is just to clean up all this multiplication, right? We can clearly see all the adding and subtracting that's going to happen in between our terms. The first one is just y to the fourth. The next one will be negative 32 y to the third when I take the 4 times the negative 8. The next one will be positive 384 y to the second. Next, I'll have a negative 2048 y to the first. And then finally, I'll have 4,096. So if we remember the Pascal's triangle, that's a 3-step process. Okay, write it all out, simplify the powers, then simplify each term. But again, on the test, there will not be anything this intensive. And lastly, in this section, we're multiplying just using the FOIL method. 6y squared minus 9y for my first outside. Inside is plus 8y, last times last, minus 12. 6y squared minus 1y when I combine the like terms in the middle, minus 12. That has been multiplied. So there we have it. There's some of the 4.2 material. Now we get into 4.3 where we are using division. So numbers 11 and 12, we're using long division to divide these polynomials out. For number 11, when I set that up, I just want to be aware, am I skipping over any powers along the way? So 2y minus 1 is what I'm dividing by, and the polynomial I am dividing is 6y squared plus y minus 2, and they don't skip over any powers. I've got y squared, then y to the first, and then just a constant. Remember that when we start these problems, we're saying, hey, what do I have to multiply this 2y by out front to match this leading term underneath? And it's 3y. So I'll put a 3y to start off my quotient in the column of y's that I have set up. I'll distribute that 3y out front to get 6y squared minus 3y. And then I want to take the difference. So I will switch the signs and then add them up. That's the same thing as subtracting. And then drop down the next term in line. And now the process starts anew. What do I multiply this 2y by to make it match 4y? Positive 2. If I distribute that positive 2 out front, I get 4y minus 2. And I switch the signs and add, I get a remainder of 0. My answer is simply 3y plus 2. There was no remainder. Let's try the next one, number 12. 3x minus 2 is what I'm dividing by. Got x cubed, x squared, x, and a constant. So again, no need for a 0 placeholder or anything to make sure all my powers are accounted for. What do I multiply 3x by to make 6x cubed? Well, it's 2x squared. And let's distribute that out front. I get 6x to the third minus 4x squared. And we'll switch the signs and add. Negative 21x squared. That first section canceled out as we wanted. Those first terms canceled out. I'll drop down the next one in line, plus 2x. What do I multiply 3x by to make negative 21x? Well, a negative 7x. Negative 7, let's distribute that out. I get negative 21x squared plus 14x. And we're going to switch the signs and add. Again, those leading terms cancel. That's what we want to happen. I get negative 12x, and I'll drop down the next one in line, a positive 8. One more time through the process, what do I multiply 3x by to make negative 12x? Well, it's negative 4. Distribute the negative 4 out front, I get negative 12x and a positive 8. And I switch the signs and add, and yet again, I have a remainder of 0. So this is my answer. If I did have a remainder, let's say that I ended up with, and just use your imagination here, let's say I ended up with a 5 here, then my answer would be 2x squared minus 7x minus 4 plus 5 as a fraction over that stuff we were dividing by, 3x minus 2. Again, that's not the answer here, but if we did have a remainder, that's how we would write our answer. So that's just something to consider. That's just an extra thought bubble that we have. Okay, so there we're getting into section 4.3 with this division, long division. Next, use synthetic division to divide the following polynomials. And here, synthetic division, it was a nice little algorithm. We got to get all of the variables, all the x's and y's and stuff out of the way so that we could just focus on the number work that was happening. So for number 13, I'm dividing by the factor y plus 2. The solution out of that would be y equals negative 2. I'm switching the sign. So when I set up my synthetic, I'm going to put negative 2 in the box. We just kind of call that it's where the divisor goes in synthetic. And then I'm looking at the coefficients of what I'm dividing up here. I've got 1y cubed minus 1y squared. I've got 0 y terms and minus 6 for a constant. I'm going to make a little corner off to the side there. That's where my remainder will end up when I do this synthetic division. And I can tell you right now, if people are making mistakes, leaving that 0 placeholder out, that is a crucial step, and it's a really easy thing to miss. All right, so now we run through the process. I drop down the first number outside the box, drop down that 1. Negative 2 times that 1 makes negative 2. That fills in the next column. I add up the column and then repeat the process. -2 times -3 is +6. I add down the column. -2 times 6 is -12, and I add down that column. So we have a remainder of -18. Here's how we interpret that answer, because we're really dividing polynomials. I should have an answer that has variables in it. This 1, -3, 6 means I have a constant of 6, a y term of -3, that was a +6, and then a y squared term of 1y squared. And then my remainder is -18, so I'm adding -18 as a fraction. What was I dividing by? Oh yeah, y plus 2. That's how I should write my answer. Again, pretty fast process, and if we've picked up the pattern, we should be having a pretty good time with these. So for number 14 here, a +3, the solution out of that x minus 3 factor goes in the box. I've got 3x squared, -2x, -21. Let's make a place for our remainder. Drop down the 3, multiply, add, multiply, add up. So I've got a remainder of 0. My answer is just 3x plus 7. That's how I interpret that 3 and 7 that ended up in the quotient area of our solution. All right, and lastly for this page, number 15. -2 goes into the box. I've got 1x to the 4th, 5x to the 3rd, 2x squared, -6x, and a +4. We didn't skip over any powers, so I didn't need any zeros there. Drop down the first, multiply, add, multiply, add, multiply, add, multiply, add. So following that procedure, again, we have a remainder of 0, so we must have divided out a factor of that polynomial. How do I interpret the answer? Well, I've got 1x cubed plus 3x squared minus 4x plus 2 with no remainder, so there's no need for a fraction at the end. All right, and what I see typically is a lot of students will go through the procedure just fine, but they don't know how to take those numbers that show up in the bottom of synthetic, these numbers right here, and put them into an answer. So be sure we know how to finish the problem off for those. All right. Our next set of problems. If we have a polynomial function given, it says use synthetic division and the remainder theorem to find each value. And you can see we're trying to find the same thing as if we would just plug a -2 into that polynomial, but man, is that a lot of work to do. Even with a calculator, that takes a long time to type out. So what we're going to do is use synthetic. Whatever the remainder is, that is the same thing as this value p of -2. Okay, so they are not giving us a factor to divide out. They are giving us a value right away. So I don't need to switch the sign here. -2 goes directly into the box. 1x to the 5th, 3x to the 4th, -7, x cubed. I don't know where that 4 came from. +2x and -6. Okay, they did not skip over any powers, so I don't need any 0 placeholders. And again, my answer will show up right here where the remainder goes. Drop it down, multiply and add, multiply and add, multiply and add, multiply. I come up with -46. Oh no, I made a mistake. -46 is not the correct answer, and I found it. It was a rookie mistake, and it's likely to creep up on you as well. That is such a long polynomial. I did not see that, or maybe I went too quickly. After that -7x cubed, there are 0x squared terms, then a 2x, then a -6. Oh man. So I need to backtrack to that point in my synthetic and say, okay, -2 times 9 here under this 0 should go in 18. Then I can keep my pattern going. and I will add, I'll get negative 34. I'll multiply and get positive 68, and I'll add and get positive 62. So P of negative 2 equals 62. And if I had time taking this test, these are problems where I can go back and easily check in a calculator just by typing in a negative 2 input. So I would definitely take the time to do that if I had it. That would point out that 0 placeholder mistake if I made that and didn't catch it. All right, number 17 is the same thing, and we're using the same function. So negative 1 goes into the box. I know my row of numbers should be the same. 1, 3, negative 7, 0, 2, and negative 6. I'm not going to leave that 0 placeholder out now. And let's go through our process. Drop it down, multiply and add, multiply and add, multiply and add, multiply and add, multiply and add. I get a positive 1. So P of negative 1 equals that remainder of 1. We have our answer. All right, we're closing in on the end of the test here. One of the final sections is to solve by factoring. Solve by factoring. And to do that, here's what 4.4 is all about. All these different factoring techniques sort of pile up here. Whenever we are factoring, we want to look for a GCF first. So in the case of number 18, I notice I can take an m squared and undistribute that from the all the terms of that polynomial. I'll be left with m squared plus 7m plus 12. And I can factor this trinomial out using magic numbers. So m squared, and then I've got m plus 3 times m plus 4. And then to find the solutions, I'm just saying, well, what would happen if each of these factors were set equal to 0? So for the first one, if m squared equaled 0, m would equal 0. For the next one, if m plus 3 equaled 0, I would simply subtract 3 from both sides, and I'd get negative 3 as a solution. M equals negative 3. And for the last one, if I had m plus 4 equals 0, I would subtract 4 from both sides. M equals negative 4 is my final solution. So here I got 3 solutions coming out of that polynomial from the factors. For number 19, this is probably one of the trickier ones of this whole section. Here we've got a sum of perfect cubes. X cubed plus 8, I can think of that as x cubed plus 2 cubed. To factor that out, I use my sum of perfect cubes rule. The first factor, the little factor out front, is just going to be that expression, x cubed plus 2 cubed, but without the cubes. And the second one, the bigger factor, will be the first thing squared, a different sign, first times second, so 2x, plus the second thing squared. 2 squared is 4. So this factor out front is going to produce an easy solution of x equals negative 2. However, the solutions here will always require the use of quadratic formula. Those are imaginary solutions. So with quadratic, x equals the opposite of b plus or minus the square root of b squared minus 4ac, that's 32, all over 2 times a. 4 times a times c is not 32, it's 16. I'm sorry about that. Moving too quickly. And we can see the negative forming underneath our square root. That's 2 plus or minus the square root of negative 12 all over 2. Now it's just a matter of simplifying. 2 plus or minus, this is going to be an I term. And I told you root 12 is a good one to memorize. It's 2 root 3. So as it's imaginary number, we call that 2i root 3. And it's all being divided by 2. I'm able to divide top and bottom cleanly by 2 because all 3 of those coefficients, those whole numbers out in front, are all divisible by 2. So x equals 1 plus or minus 1i root 3 should be my final set of solutions. And I did mention this in class, but on the test, this, our main focus is the factoring. So a problem like this, the factoring is worth 2 out of 3 possible points. The final point comes from finding the solution. So if we see that as a very arduous task, we understand that it is. Realize that we see the factoring as the most important. For number 20, I've got 4 terms. I don't see a GCF that I can take out, so I know that 4 terms, my only hope is factor by grouping. So I set up my 2 groups. What can I take out of that first group? Well, a 3x squared, and I'll be left with an x and a positive 2. And from that second group, I want to leave behind another factor of x plus 2. To make that happen, I would just divide it by 1. I really need to see this number 1 out front. I know I didn't change anything about the factor, but to not change it means I divided away a 1. Now I can set up my 2 factors. One of them will be the terms outside, 3x plus 1, and the other will just be one copy of what we see duplicated left in parentheses, in this case x plus 2. And of course that's still set equal to 0. We're still solving. So I really should have had an equals 0 up here. Remind myself that it's still an equation. I want to end up with x equals something for an answer. So this factor right here, x plus 2, is going to give me x equals negative 2 for an answer, and that's a pretty easy one to find. However, this other factor, if I set that equal to 0, I would end up with 3x squared equals negative 1. Then I'd divide both sides by 3. And I take the square root of both sides. Since I took the square root of both sides, I need plus or minus square root of negative 1/3. It is an I term, so it's I root 1/3. This would be acceptable for full credit for me. We have not covered rationalizing denominators as part of a lesson yet. However, if we do know how to rationalize the denominator with this, and you end up with x equals plus or minus I root 3 over 3, you will get an extra credit point for that. You're going above and beyond if you do that. So quite a few little opportunities for extra credit on this test. Number 21, this, if we look at it, we've got 3 terms and I can't combine those together. Let's get that set equal to 0. It's kind of looking like a quadratic to me. And now if this were just x squared and 4x to the first, I know I would just factor that using magic numbers. Let's do that right here. Except I got to remember that my first times first has to make x to the 4th, so my factors, instead of being x and x, they've got to be x squareds. That's the only difference here. I'm still finding magic numbers like minus 7 and plus 3 that multiply to be negative 21 and add up to negative 4. And now I just go about my solving. If this first factor were set equal to 0, I would have x squared equals positive 7. Then I'd square root both sides. X equals plus or minus root 7 is part of my solution set. For the second factor, I would have x squared equals negative 3 as I start my solving, and I would square root both sides. I'd find x equals plus or minus the square root of negative 3, and it's an imaginary pair of solutions there, so I would just call that I root 3. Treat it like a bluegill, right? Take the i's out. Take the i's out first, and we've got our answer. Can't simplify the radical any further. Number 22, we've got another sum of perfect cubes. Oh, sorry, this is a difference of perfect cubes. It's x cubed minus 1 cubed. So I'm going to go ahead and factor that out. I've got my first factor, the little one, that's just that expression without the cubes, x minus 1. And then the bigger factor, I've got the first thing, x squared. I change the sign to positive. First times second is just 1x. And then plus second thing squared is a positive 1. Out of that first factor, it's pretty easy to spot. I should get x equals positive 1 as a solution there. And as we said in problem 19, this big factor is going to require quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And we got a little bit of cleaning up to do with the radical. That's negative 1 plus or minus square root of negative 3 all over 2. To finalize this, we simply need to note that we have an imaginary number there. So I root 3 takes the place of square root negative 3, and we have our solution. And the final problem here, let me get my recording window out of the way. Problem 23, very much like problem 21 that we have directly up above, so we can refer back to that. It follows the quadratic form. So x to the 4th plus 5x squared, let's get it set equal to 0 so we can use our quadratic factoring tricks. Okay, and I just noticed that yet again I forgot that equals 0 over there. I won't take off points for that. It's just important to realize that I want to end up with x equals something for an answer. So if I get rid of that equal sign in my steps, sometimes I forget that. All right, so yet again, we've got some magic numbers factoring that's going to take place. I need first times first to make x to the 4th again. So we got x squared and x squared. Magic number time, what multiplies to be negative 14 and adds up to positive 5. That's a positive 7 and a negative 2. For that first factor, if I set that equal to 0, I'll get x squared equals negative 7, and then square root both sides, x equals plus or minus square root of negative 7. And those are imaginary solutions, so plus or minus I root 7 should be that answer. For the second factor, I would have x squared equals positive 2 as I set it equal to 0 and start to solve. And I would square root both sides, which means plus or minus, and square root of 2. Solutions coming out of that. Again, I can't stress this enough. The main focus here is the factoring. So if this seems like an unbelievable amount of work, realize what's important to us, the teachers, as we are grading this. The solutions will just be the final point out of 3. Also, you will not have this many problems on your test. I believe there are only 4 solved by factoring problems on your test. All right, and our final slide, final section of our review, if we have a polynomial and one of its factors, find the remaining factors. Well, if we have a factor, it means I should get a remainder of 0. That, in number 24, this x plus 1 should divide that polynomial cleanly, leaving a remainder of 0. So if I carry out synthetic division, again, they give me a factor, so I want to take the solution out of that factor. Let me be absolutely sure that I don't need a 0 placeholder. I do not. I should see a 0 for a remainder. Otherwise, I'm doing something wrong. They're telling me it's a factor. I'd better see a 0 there. If I drop down the 1 and I multiply and I add and I multiply and I add and I multiply and I add, sure enough, remainder is 0. So I need to find the remaining factors, and actually on the test it will say write it in completely factored form. So that will be added on to the instructions, write it out completely factored. I'm going to show you how to do that. So what this means is 1x squared minus 2x minus 3 for my remainder, sorry, not remainder, my quotient. And if I wanted to factor that, it's a pretty straightforward magic numbers factoring routine. So my function f of x equals those two factors times the x plus 1 that we already divided out at the beginning. So here we have our fully factored polynomial. And the nice thing about this, I've got 1, 2, 3 factors for a third degree polynomial. There's a nice little check there. Let's try 25. So x minus 1 is the factor. That means positive 1 goes into the box. I've got 1x cubed, 0x squared, negative 3x, and a positive 2. Let's go through synthetic. Drop down the 1, multiply and add, multiply and add, multiply and add. All right, I'm feeling pretty good. I got a 0 remainder. That's exactly what I wanted to see. This quotient underneath means 1x squared plus 1x minus 2. And yet again, we get a nice, friendly magic numbers factoring. So my function f of x in fully factored form we'll have that x plus 2, that x minus 1, and that other factor of x minus 1 that we divided out with synthetic. Now, it won't happen every single time that this matches what we divided out. I know we saw that in these two examples. It won't happen every single time, so don't feel like that's something you should expect to see. That just happened to occur in these two examples. And the final one, problem 26. We've got a factor of x minus 3. That means positive 3 goes in the box. 1x cubed, 4x squared, negative 15x, negative 18. We didn't skip any powers. No need for a 0 placeholder. Drop down the 1. Multiply, add, multiply, add, multiply, add. Really, really happy I see that 0 remainder. That means my synthetic is spot on. So I'm left with x squared plus 7x plus 6. And if I factor that, factor out my quotient, again, magic numbers, plus 6, plus 1. So in fully factored form, this function would have x plus 6, x plus 1, and that factor we divided out, x minus 3, for our fully factored answer. Okay, I do know, again, like I said at the start of the video, I understand that I went pretty quickly through this, but you can see even taking the time to explain it only took me 40 minutes or so. So I would hope that as you're going through in a 50-minute class period and doing work like this, understanding that the last slide with all the solving, there's not going to be that many, I would feel that we would have plenty of time to go through and feel confident, check our work, all that stuff as we're sitting down to take the test. I hope this has been a helpful review for you, and I wish you good luck on the Chapter 4A test in Algebra 2.